Welcome back. Today we reach the edge of our understanding. We've explored stars and galaxies, but now we face the force that will end them all: dark energy. In 1998, two independent teams made a discovery that shook physics to its core. They found that the expansion of our universe isn't slowing down, it's actually speeding up. By observing Type 1a supernovae, stellar explosions so consistent they act as standard candles, astronomers realized these markers were much fainter than expected. This discovery earned Saul Perlmutter, Brian Schmidt, and Adam Rees the 2011 Nobel Prize, proving that some unseen force is pushing the cosmos apart. We call this force dark energy. It's not like the matter we know. It doesn't clump. It's a property of space itself, exerting a repulsive pressure. Look at the cosmic balance sheet. Dark energy makes up nearly 70% of everything in the universe. Dark matter is about 26%, while everything we can see, all the atoms, is just a tiny 5%. Einstein originally proposed a cosmological constant to keep the universe static. He later called it his biggest blunder, but today it's our best model for dark energy. We think it might be vacuum energy. Even empty space has energy, and as space expands, more energy is created, pushing the expansion even faster. But there's a problem. Quantum theory predicts a vacuum energy 120 orders of magnitude larger than what we observe. This is one of the greatest mysteries in all of science. Another theory, called quintessence, suggests dark energy isn't a constant, but a field that changes over time and space. We are still testing this today. To understand the future, we measure the Hubble constant, the rate at which the universe is currently expanding. But the numbers don't match. This is the Hubble tension. Data from the early universe gives us about 67 kilometers per second per megaparsec, but local measurements say it's closer to 73. Recent 2025 results from the Dark Energy Survey and DESI are tightening these constraints, but the tension remains. Something in our model is missing. Whatever its nature, the dominance of dark energy points to a singular, inevitable destiny for our cosmos: the Big Freeze. As space expands faster and faster, galaxies will be pulled beyond our cosmic horizon. In a few 100 billion years, they will vanish from our sky forever. Our local group will merge, becoming an island universe in a vast, empty void. Any future astronomers would see a sky with only one galaxy. In about 100 trillion years, the last stars, tiny red dwarfs, will exhaust their fuel. The lights of the universe will begin to go out, one by one. This leads to heat death. According to the second law of thermodynamics, entropy must increase until energy is perfectly uniform. When maximum entropy is reached, no temperature differences remain. No energy can be exchanged. No work can ever be done again. Even the mighty black holes will slowly evaporate over unthinkable timescales, about 10 to the 100th power years, through Hawking radiation. The universe becomes a thin, cold mist of particles, asymptotically approaching absolute zero, a silent, eternal whimper. While some studies in 2025 briefly challenge this, reanalysis in mid-2026 confirmed that our cosmic acceleration is very real and as strong as ever. Upcoming facilities like the Vera C. Rubin Observatory will search for definitive answers. We are on the verge of understanding our ultimate end. Why do we look so far into a cold future? Because to know the end is to truly appreciate the middle, this brief, luminous era where life can exist. We live in the universe's golden age, where stars burn bright and galaxies dance. We are the way the cosmos knows itself. Our existence may be a fleeting spark in the dark, but that spark is everything. Our curiosity is the bridge across the vastness. Dark energy may be our destiny, but for now, the universe is ours to explore, to question, and to marvel at. That concludes our 10-lesson journey through the cosmos. I hope you've enjoyed this exploration of the physics that governs everything. You've mastered the cosmos, from the Big Bang to the Big Freeze. Keep looking up. The stars are waiting. I'm James. Thanks for watching James's Physics 101. Don't forget to subscribe for more journeys into the heart of the universe.